Welcome to Section 9, Lesson 6. Three types of variation appear constantly in physics, geometry, and applied algebra: direct, inverse, and joint. Each one says how one quantity changes when another changes, and each one has a single constant k that captures the relationship. Direct variation says one quantity equals a constant times another, y equals kx. As x grows, y grows in lockstep. The graph is a straight line through the origin with slope equal to k. Inverse variation says one quantity equals a constant divided by another, y equals k over x. As x grows, y shrinks in proportion. The product x times y stays constant. The graph is a hyperbola with two separate branches. Joint variation extends direct variation to two driving variables. Z equals k times x times y. Z grows when either x or y grows, and the constant k is found from one known triple of x, y, z values. Three small panels show the three variation curves side by side. Each panel has its own equation, its own graph, and its own behavior to watch. Direct variation. Pick k equals 2, so the equation is y equals 2x. The graph is a straight line through the origin with slope 2. As x grows, y grows by exactly twice as much. Doubling x doubles y, tripling x triples y. Inverse variation. Pick k equals 2, so the equation is y equals 2 over x. The graph has two branches, one in the first quadrant and one in the third. As x grows, y shrinks towards 0. The product x times y always equals 2, no matter where you stand on the curve. Joint variation. Pick k equals 2, so the equation is z equals 2 times x times y. Holding y fixed, z scales linearly with x. Holding x fixed, z scales linearly with y. The constant k is the slope per unit of the product xy. Example 1. Y varies directly with x. We are told y equals 12 when x equals 3. Find the constant k, then find y when x equals 7. The line below is the answers graph plotted as we go. Solve for k. Direct variation says y equals kx. Substitute the known pair 12 equals k times 3, so k equals 4. The variation equation is now y equals 4x. Find y when x equals 7. Plug into y equals 4x. Y equals 4 times 7 equals 28. The two known points sit on the line 3, 12 and 7, 28, both on y equals 4x. The constant of variation is 4. The full equation is y equals 4x, and the answer to the question is y equals 28 when x equals 7. Both points lie on the same straight line through the origin, exactly as direct variation requires. Example 2. Y varies inversely with x. We are told y equals 6 when x equals 4. Find the constant k, then find y when x equals 12. The hyperbola plotted below is the variation curve. Solve for k. Inverse variation says y equals k over x. Substitute the known pair 6 equals k over 4, so k equals 20. 4 equivalently x times y equals 20. 4 for every point on the curve. Find y when x equals 12. Plug into y equals 20, 4 over x, y equals 20, 4 divided by 12 equals 2. The 2 points 4, 6 and 12, 2 both sit on the curve on opposite sides of the bend. The product x times y stays constant at 20, 4 along the entire curve. As x grew from 4 to 12, y shrank from 6 to 2, and 4 times 6 equals 12 times 2 equals 24. That is the inverse variation signature visible directly on the graph. 3 takeaways for variation problems. Each one describes a different way two quantities can be linked. Direct variation links y to x linearly. Y equals k times x. The graph is a straight line through the origin. To find k from a known pair of values, divide y by x. To find y from a new x, multiply that x by k. Inverse variation links y to x as reciprocals. Y equals k divided by x, or equivalently x times y equals k. The graph is a hyperbola with two branches. To find k from a known pair, multiply x by y. To find y from a new x, divide k by that x. Joint variation extends direct variation to two driving variables. Z equals k times x times y. To find k from a known triple, divide z by the product xy. To find z from new x and y values, multiply k by their product.